Hi, my name is Joseph, and I'm going to be explaining how I got all these graphs and these points that make up the graph or that are plotted on the graphs, and like just how they're derived from this clip that I have. So basically the motion of that cart was moving in the positive direction with the steady speed. The constant or changing nature of this position versus time graph, it's more of a constant nature because each of these separate dots are going in like moving in a straight line sort of. Therefore, you know that the speed might be constant because each one, it's like a repetition. Every second it's moving the same speed or same distance. The vertical intercept of the position versus time graph is position for mine, and it basically like shows how far, or no, not how far, like where it is exactly from 0, or like the beginning point. So like say if we went to about 1 on the position, that would be like 1 foot away from the original position of 0. So basically all these terms or coordinates that you see right here in black and red represent like the points on the position versus time graph. Or can we scroll down? No. Well, anyways, yeah, like just like one of these points right here would represent, say, a point down here, and they all move like in the image or shape of the straight line. So therefore, again, you know that these probably make up a constant speed. Considering then how far the object has traveled in about 1 second, which is about, I would say, around 0.76, I don't know, around 0.76 meters per second. So since this line is straight, you know that in like 2 seconds it might be 1.5 or something like that, as from here. So yeah. Okay, so basically now I'm looking at my velocity versus time graph. You probably noticed earlier that this wasn't there. I unfortunately forgot to put it in earlier, but yeah, now it's here. And basically, so far you see how this is a straight line. Overall, it is kind of the same velocity, so therefore it's not changing. So if you have a constant velocity, then you have a constant speed. You could think of it in that way. Again, now this slope of this velocity versus time graph, or instantaneous velocity, feet per second, versus time, seconds, it's also similar to what I thought might have been the constant speed before, like of how it might have been about 0.76. Well, also right here, this line, the velocity also lies around 0.76, just to see the relation. So like the distance traveled every second is about the velocity, I suppose. Yes. Okay, so the equation right here, m slope, that would basically be representing like the change or slope in this velocity versus time graph. You may notice that it is a very, very, very small number. That's because most of the time, or from here, you would know that this is a constant speed, and also that since this velocity versus time graph is more of just a line going across, then you'd know that it's not really changing at all. It's just going to stay the same. It doesn't change at all. So like it's going to stay about 7.76 meters per feet per second, and that's going to be the instantaneous velocity. Okay, now to find the now to find the displacement of this velocity versus time graph, or basically the displacement overall, like the change in position, all you have to do is find the area of this area under the velocity versus time graph, or above if the velocity versus time graph is below 0. So basically, you have about right here your y-intercept is 0.8005 feet per second. So you know that the height of this area is going to be 0.8005, and you could just multiply it by this right here, or about like the end point, which would probably be about 2.5. So that would be 2.5. And basically your area of, again, a rectangle or like any figure or shape like this would be base times height. So again, base 2.5 times height, 0.80005, is equal to around 2.00125. We could just assume it's 2. So basically the car, or the FPV, traveled about 2 feet in 2.5 meters, or when this final point is hit or detected.